Hey everybody, it's Tyler here at Michigan State Championships, checking in team number 2337, EngiNERDs. I'm here with Emily, Nate, Christian, and Madison. And you got to check out this awesome machine. It's performing so well here at MSC. They already have a win under the belt at Livonia. We got a lot of cool different models and features to show off to you here. And I can't wait to talk more about this robot on Behind the Bumpers.
Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register.
So let's start off on your intake here. You guys got this the over bumper intake. I've seen a couple of these, but I love them overall, and we got a cool model to show off. So talk to me about your decision process between this type of intake, and then also talk about the model you have too.
So we can demonstrate it really quick. Zora. So what you just saw, starting off, this is a miniature model here. So the way that it releases at the beginning is we've got a motor, which typically would be up here, and then we run the rollers so it actually self-deploys using this cam wheel here. And the reason for that is that at the beginning of the season, we decided that we wanted a very robust intake, and we wanted to use a high pivot. That way we can take a lot of hits, as you can see here. And also to keep it as simple as possible, we didn't want to use pneumatics unless we had to. So by using that self-deploy method, we don't have to use pneumatics. We use gas struts, which are right here, and then rubber bands. And then this 3D printed piece here has a slot in it so that once it goes out, it can kind of like, as we're intaking balls, go up and over and kind of like pull them in. And then what we refer to as the dog bone piece is here. So then these spin, we've got mechanisms which guide it towards the center, and then also it naturally wants to follow this radius of our delivery system plate, and then the dog bones push it the rest of the way in.
On your intake here, this roller they have, what kind of material is this? And then how did you test this out with the cargo?
So this is traction tape right here, just like similar to what you would use outside of your house,
Sure.
On steps or your garage. We had heard about other teams that had success using this tape, which is what led us to it. It wasn't the first thing that we tried though. Originally, the flex wheels that we use up here, we just had a complete full roller of them in the front. However, it was very heavy. So instead we decided that we wanted to try some different things. Then we tried PVC wrapped in foam, except then the foam, we wrapped it with shock cord to prevent it from slipping, except then the shock cord ate away at the foam. So that worked well, except we decided that we wanted something that we didn't have to worry about changing out every once in a while. So we've been using this front roller since Troy. We've got backups prepared just in case, but we like it a lot. It's been working really well.
I mean, it seems like it's been working quite well, no doubt. Let's keep moving on into your index or your shooter. Nate's going to talk a little bit more about that. And love to hear just in regards to how that transfer comes through, and then from your shooter perspective on that, with your great sword drive, you don't necessarily need a turret or anything like that, but I'd love to just hear the full thought process on that too.
Sure. So going into the game this year, we had a couple of different objectives and ideas for how the game would run. One of them being that we thought the amount of balls in the field would be very limited because you have balls in the hub that are being stored at the moment. You have balls behind the glass in the terminal area. They're all over. They're bouncing. And so one thing that we wanted to do was help starve or to hurt the opponent team is to help starve them. And so by starving them, we mean if we're the Red Alliance, we can grab a blue ball and keep it in our robot the entire match. And then so they have one less ball. So instead of 11 balls out there, they have 10. And so we had to design a serializer that allows us to hold an opponent's ball at the same time as us scoring our ball. And so the way we did this was we found something called a Spindexer. And so what the Spindexer does is it allows the ball to intake from the bottom. Emily, is there any way you could do this for me? Thank you. So if you intake from the bottom, the ball circles around the Spindexer until it gets to the top. It's reached to the top and it stops there due to our sensors that Madison will talk about later. But so if there's a blue ball here and we identify we're red and we don't want to shoot that, and we intake a red ball, we can send this to the bottom while the red ball comes to the top. we shoot the red and we hold on to that, therefore starving our opponents.
I love that, by the way. There's I've asked other teams about that, like, hey, what happens if you pull, you know, the wrong one in and then the correct one, or vice versa? And sometimes they don't have a necessarily a comprehensive answer to that. I love that you thought out that process.
Sure.
By the way, Spindexer is not a term I've heard that much this season. It's something we heard a lot last year.
2020 was huge, and this year we were like, okay, there were a lot of Spindexers in 2020. They were effective, but we think this year's even more effective. So one way, but most of the Spindexers in 2020 were horizontal. Ours was vertical, because one thing we did this year was our robot, if you look at it, is very, very small chassis dimensions. We're 24 by 24 for a couple reasons. One, the hub is huge, and we wanted to sneak through the size. Also, being able to climb. One thing we've seen recently in like week 5 and week 6 events is the triple traversal. And so if you find robots that are skinnier, that's something we did. But we worked in with those bounds and figured out the math is very, very skinny. There's like an inch or 2 on each side to give. But the Spindexer vertical is very helpful for that.
So when are we going to see a triple traversal from EngiNERDs?
Again, look out.
All right, well, actually, with that, that's a great segue to go into Christian, and maybe he can answer that and talk some more about the climber. And I'd love to hear anything from, like, if we can maybe show off your climber sequence or anything like that as we go through, too.
Absolutely. So one of the first things we discussed on our team was if we felt it was important to be fast or to be more slow and you can do multiple things. What we decided was that the speed is what won out and we didn't need the high run. So we designed our climber to skip from the mid run straight to traversal because we figured we could make it faster and more reliable and more last second climbs if we had to. So we started with an elevator, which is just a general 2-stage elevator. This allows us to climb on the low and mid run. So if we ever need to do that, for example, if an alliance partner has already achieved the traversal run climb and we do not need to do it ourselves, then we can use this and we can lock down the rest of our system so that we only get the mid and low run. Once we're ready to do traversal, we use the same elevator, we grab the mid run, and then we will actually fire these servos at the bottom, which we can actually release one of them now, carefully. It's a little bit violent, so you got to stand back.
All right.
So these arms are what we call the extension arms, and they're used to grab the traversal run. And these are the reaction arms, and these actually just press against the high run.
Yeah.
So when we pull ourselves up, the high run will come down here and actually push these because the robot will try to tip itself back. So this prevents it from tipping too far so that these can stay in line with the fourth run. So as we come into the fourth run, these are ratcheting hooks that will actually grab onto it when pressed. So that way when we grab the fourth run, we know we are on it and secure it, and we don't have to worry about getting hit by an alliance partner or hitting the drive station wall too hard and falling off. At that point, we just raise our elevator, which is now tuned thanks to this little gusset. So that will lift right off the second run without any extra force. These will swing back, and then the reason these are able to flex is because rather than have to drive these back down, we can actually just let these swing past the third run, and then these will pop off. We're only on the traversal, and now we're safe.
How long does it take you to typically climb, or what do you want to get to, I guess, in regards to timing on that?
We typically leave to climb about 15 seconds. The climb itself is around 7 to 9 seconds. The main question is that when we go up, these runs have to go above the third run for it to function. So if these go under, then we have to go back down and get up again. So that can lead to a little bit of inconsistency. When these go up on the first try, we can get a 5-second, but we don't usually do that.
Let's wrap up this robot. I know there's a lot of sensors on the spot that we want to overview and cover, so let's talk more about, from a programming and sensor standpoint, on what's on your robot.
All right, so starting from the ground, we have a camera right here, and on that camera we use photon vision, so very similar to how people use a limelight to track the hub. We use photon vision to track the balls, so the robot will actually strafe left and right when it sees a ball, so that our ball lines up center on our intake. So once we've run the intake, we have beam brake sensors right inside here. So when we trip those sensors, it'll trigger the delivery to start spinning. So we're gonna spin the ball up to where it is now. And then right in here, there's a little tiny sensor. It's a distance sensor. So when we see a ball there, we know we're lined up and ready to shoot, so we stop the delivery. Along the path of delivery, we have 2 color sensors. There's one down here before we reach the shooter and one right up at the shooter. This is so we always know what color ball we shoot before we actually shoot it. So if we're red and we pick up blue, like in this case, we see that we picked up blue and we're like, we don't want blue. So we'll actually turn on the shooter at a very low speed and just like plop the ball out of us. The other scenario is we pick up a red first and then a blue. We want to be able to shoot the red, so we'll turn the shooter on full speed, we'll shoot the red. But as the blue's coming around, we don't want to shoot the blue at the same full speed. So instead of slowing down the shooter, we just raise this arm up to about
I love it, yeah.
And we use this as a backboard and just bounce it off the back.
That's great.
This way we don't have to worry about turning down the shooter speed up and down throughout the match. And it allows us to stay consistent and just keep cycling balls through, so we don't worry about picking up red or blue, we just pick them all up. So moving on to shooter, we have an automatic and dynamic shooter. So we use the limelight to judge distances from the hub, and based on those distances, we calculate the speed our shooter needs to be at, so we don't have to worry about shooting in a certain range. We can just shoot anywhere we want. And then additionally, we have automatic shooting, so whenever the robot is lined up and the shooter is up to speed, it will take the shot.
So you don't wait on the operator to shoot?
We do not wait on the operator to shoot at all. So the operator has a prep shooter button.
Sure.
So that we're not just shooting balls randomly throughout the match. And then as soon as that button's pressed, the shooter's up to speed, and we're lined up on the hub, we just take the shot and then we can move on. That really helps speed up our cycle time so we can cycle balls through quicker. And then climber sensors, we have a string pot right here, so we know how tall the climber is. So this right here is about the height it would be to reach the mid rung. So we look at this distance right here, and once it's like up maybe about here, we trigger the servos to release and these arms to extend. This way, we can move the climber up and down during the match, and we won't trigger these to extend. And only until we go to climb will they actually fully extend.
Well, engineers, I really appreciate you taking the time to speak about it. I love the backboard concept, by the way. I think it's really cool, Madison. So thanks a lot. Wish you best of luck here at MSC.
Thank you.
And, of course, looking forward to a World Championship berth as well, too. So good luck the rest of the way.
Thank you.
First Updates Now is supported by the Milwaukee School of Engineering. MSOE offers week-long summer camps where high school students get to preview college by living on campus, exploring engineering programs, experimenting in labs, meeting with professors, and participating in fun group activities. Are you ready to experience STEM at MSOE? Visit msoe.edu/summer to learn more and register. Thanks to Stryker Careers for their support in this video. First, alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.